Okay, can you all hear me?
Yes, sir.
Solomon, can you hear me?
Yes, I can hear you.
Awesome. Nick, can you hear me?
Yes, sir.
Okay, good. We're just waiting for Lydia to join in. Okay, I think she's in now. Good. Okay. So, Lydia, can you hear me?
I'm finally in. I think my network is really acting up.
Yeah, yes. It's actually,
Out of the last minute meeting before it ended.
yeah, I noticed that. It's most likely your network, honestly.
I think it's my network. I even had to restart my system.
Okay. Okay, fine. So everybody can hear me. Any questions on what we've done so far? Hello? Hello? Any questions so far?
From my
Hello,
end,
sir.
no.
Yeah, Lydia, you were saying?
Hello.
Yeah, I can hear you.
Okay. I wanted to ask, it's still the same, almost the same question of what I asked yesterday.
Yeah.
I know it's going to be practice, but is there a way we can get to know all these? Like for me, I don't know all the shortcuts you used to use to get most of those your command prompts.
Like which and which?
Like when you were using that pipe, what's it called?
Pipe operator.
Pipe operator. How
Yeah.
you were getting the percentage, the greater than sign and the percentage at the same time. You didn't have to be typing it in. How do I achieve that?
Did you watch the videos of yesterday?
I didn't watch it again, so I'm like
Okay, because if you had
I
watched the
had
videos
a
of
load of
yesterday,
work to do after the training.
we talked about it, of the shortcuts to get to it. So for pipe operator, you click Control, Shift, and M, the letter M for money.
Oh, that means I wasn't online then. I think I wasn't online when it was treated.
Okay, so that's the pipe operator, Control, Shift, and the letter M. For assignment operator, you click the Alt and then the minus sign.
Okay. And
So
that one, I know that one.
So those are the short. So for pipe operator is Control, Shift, and M.
Okay.
Yeah.
I'll watch it again. That won't be
So
lacking behind.
so we talked about
Thank
that
you.
yesterday. Okay, fine.
Okay.
Okay, so we've looked at select, so we're looking at filter now. And the last thing we mentioned was that for filter is used to work on observations, which are the values, while select works on variable names. So that's something you have to bear in mind. So like I said, if we wanted to get from, let's look at the set again, Star Wars. I said, if, for example, in eye color, we're interested in looking at only the observations where the eye color was yellow. So what we will do is we'll tell R the data set we're working in, which is Star Wars, and then we put in our pipe operator, and then we say filter. And then when we say filter, we open up the bracket and we tell R, first of all, the variable name that we're working with, which is eye color. And then we put 2 equal signs. And then we put the name of the value of the value within that eye color, which we're interested in. And it's put in inverted commas because we're dealing with values. When you are dealing with values, which are not numerical, usually you put them in inverted commas so that R understands that they are values. Okay, so what this code means is that we're telling R, wherever eye color is equal to yellow, I want you to filter it out. And when we run this command, if you look at the console, it has eye color and it has only the eye color which is yellow. You can see all in this place is yellow, 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 yellow. So we have filtered out only observations where the eye color is yellow. We can do the same for, let's look at the data set again. So let's assume we're looking for, okay, let's use mass. Mass. These are the weight of the subject. Okay, so let's assume we wanted to view only observations where the mass is greater than 120. We only want to see those that have weight of greater than 120. So we come and tell R. You always tell R first what data set you're working on, which is Star Wars, and then you click your pipe operator, go to the next line, and you say filter. Now you tell R the variable. The variable we're working on is mass. And we want mass which is greater than, so use your greater than sign, 120. So notice when I used yellow, which is character, I put it in inverted commas because it's a value. But if you're using values which are numbers, you don't need to put them in inverted commas. If you put a number in inverted commas, R will assume you're dealing with character and you might not get your results. So what this code is saying is within the Star Wars dataset, I want you to filter out anywhere where mass is greater than 120. So if I click Control Enter on this, if you look at the console, this is the column of mass, and every value of mass here is greater than 120. So we'll have 136, we'll have 135.8, we'll have 140, 159, and 136. So they are all greater than 120. So that's how to use filter. And then you can combine 2 different variables. For example, I can say Star Wars, and I put my pipe operator, and I tell R, I want you to filter variables which the mass is less than 100, and you put your and this a place where you can use your and the eye color is equal to blue, for example. I hope there is blue in eye color. Okay, yeah, there's blue in eye color. Okay, so what this command is telling R is within the Star Wars dataset, anywhere where mass is less than 100 and eye color is equal to blue, and I want to see those observations. So if we run this code, Control Enter, you can see for the mass, all the mass are less than 100. You can see 77, 75, 84, 79. But if you also look at the eye color, all the eye color are blue. So that's what this code has done. It has given us observations in which the mass is less than 100 and the eye color is blue. Okay, you can also use filter in and now I want Abubakar Mutala to pay attention. You asked me about the in operator, so I want to use the in operator now. So if we say Star Wars, let's look at the data set so I can tell you what I want to do. Okay, so now let's assume I want to select eye color, but I don't want all the colors. I just want red, blue, and yellow. Red, blue, and yellow. There are other colors in the eye color, but I just want to see red, blue, and yellow. So I come to my script. So usually what I will do is filter, and I'll say filter eye color is equal to red, or then this is where we use or. So we use our or, eye color is equal to blue, another or, eye color is equal to yellow. Okay, so this code says within the Star Wars dataset, I want you to filter the observations where eye color is equal to red, or eye color is equal to blue, or eye color is equal to yellow. That's what this code is saying. So if I run this code, it will bring out observations where the eye color is either equal to red or blue or yellow. So let's run this command, Control Enter. Now, if we look at the console in eye color, it has blue, it has yellow, and it has red. And those are the only colors you can see within this column of eye color. However, there are some times maybe you want to put in more values, and it will be cumbersome writing eye color equal to red, eye color equal to blue, and that's where your in operator becomes effective. So you say Star Wars, and then you put in your pipe operator. You go to the next line, you say filter, and then you open up your bracket. You say no, there's something wrong. Okay, I made a mistake. Instead of writing Star Wars, I wrote Stars Wars. So this is a very peculiar thing in R. If you make any mistake with a comma, or you put in a letter where it's supposed not to be on, it will not, it will give you an error. So you have to be very careful when you're typing things. It has to be exactly. So it's just like garbage in, garbage out. Whatever you type, that's what it will give you. So you need to be very careful. So you can see why I noticed that I made a mistake is as I type I underscore, R is supposed to immediately give me options to show me, okay, you want to type I color. But when I didn't see that, it gave me an idea that there must have been an error somewhere in my code. So I now saw that I wrote Stars Wars. There's an extra S here instead of just Star Wars. So I'm just going to delete that. So if I start typing this I now, you see it has shown me eye color. Good. So eye color, then you put in your in operator, which is percentage in percentage. Then you want you write C. C is like a combination of. It means concatenation, which means a combination of. Open up your bracket and you write red in quotes, comma, in quotes blue, and then in quotes again yellow. So this code is the same as this code on top of it. But you can see it looks neater because we didn't have to write I color equal to I color equal to I color equal to. So that's where this in operator comes in handy. Mutala, like you were asking me. So what this code is saying is within the Star Wars data set, I want R to filter any place where any of these values, red, blue, or yellow, is inside I color. So that's what this in operator is saying. Anywhere where red, blue, or yellow is inside I color, I want R to filter out the observations. So if I run this code, so it still gives me the same thing as the earlier code. So it has given me observations where I color is either blue, yellow, or red. So that's a place to use your in operator. Notice that there is a C here, and this C is to combine the three colors. Instead of writing them separately, I color equal to red, I color equal to blue, I color equal to yellow, you put a C to combine the three of them, and that is where your in operator comes in very handy. Okay, notice that we had a bracket in the beginning here, and then when we wrote C, we put in another bracket. So the number of brackets you open must be equal to the number of brackets you close. So one bracket open here, one bracket open here, which is 2. We also have to close 2 brackets. So notice all these little nuances. If you miss out any of them, it will give you an error. If you miss out any of them, it will give you an error. Okay. So that is filter. So we've looked at how to use filter. We've looked at the single eye color is equal to yellow. We've looked at how to use filter mass is greater than 120, or combine it and say mass less than 100 and eye color equal to blue. We've also looked at how to use the OR operator. This bar means OR. If you watch the videos of yesterday, we also looked at it. And then we've also looked at how we can use our in operator with filter. Okay, so that's we've looked at rename variable, we've looked at recode, we've looked at mutate, we've looked at select, we've looked at filter. So these are key functions that you use in data cleaning, data manipulation, to help you arrive at a platform where you can start analyzing your data. Okay. One more thing I'd like us to look at before we round up for today is missing data. Sometimes when you have a data set, it might contain data that is missing. In R or in data parlance, we call that NA, which means not available. That's NA like this. So that's usually missing. So wherever there's no data, R puts NA. For example, if you look at the console under hair color, this one, you can see NA in red. So R is indicating that in these places there are no data available. So usually when a variable contains missing data, especially if it's a numerical variable, you are usually unable to calculate certain statistical parameters with that variable, because R will not understand what to do with the missing data. For example, if you have a numerical data and you want to calculate the average or the mean means you add up all the variables in it, all the values in that variable, and then you divide by the total number or by the frequency. Now, if there is a missing data within that variable, R will not understand what to do, how to add a missing data to other numerical variables. So if you ask it to find the mean of that variable, it will just tell you NA. It will just tell you missing data, because it doesn't understand what to do with that missing data. So usually, sometimes when we are dealing with such kind of things, we might choose to remove the missing data from that column before we can apply that statistical parameter to that variable. Let me show you an example of what I mean. So let's look at the Star Wars data set. Okay, so let's take, for example, height is a numerical variable, and we want to calculate the average or the mean of the heights within this data set. So if we go to R and we say Star Wars, and we put in our type operator, and we say give us the mean of the height variable, and we click Control Enter, you can see in the console, this is the code that we have typed: Star Wars, type operator, and then mean of height. The answer it gives us is NA. And then it gives us a warning message. It says in mean default height, argument is not numerical or logical, returning NA. So that is because there is missing data within that variable. But if we want to still find it, we need to remove those missing data. And what we'll do is Star Wars type operator, and then we say mean of height, and then we write comma, and we write NA.rm, which means remove the missing data. RM means remove, and then we write true in capital letters. So what this code is saying is the same thing as the one on top. However, it's saying remove the missing data before calculating the mean of this. Now, if we run this one, Control Enter. Now it's still telling me this. No, it's not supposed to do that. It's supposed to, and come, let me see. Mean Star Wars $sign height and a remove equal to true. Okay, so if I run this, Control Enter. Okay, so it has given me the mean here as 174.358. Let me separate this. So let me run it without the NA.rm, without removing the, so mean Star Wars and then height. So if I run this, Control Enter, okay, so you can see if I run without the removing the missing data, it returns as NA. It gives me NA as the answer because there are missing data. But if I remove the missing data by saying NA.rm equal to true, it gives me the value of the mean. So that's one way to deal with missing data. Then another way is, first of all, you might want to know exactly where you have missing data in your data set. So let's use Star Wars. Let me select a few data sets and a few variables within Star Wars. So Star Wars, we'll put in a pipe operator, and then I say select. Let's say I select name, gender, height, and hair color. Okay. So if I put in my pipe operator here again, if I say filter complete cases. So complete cases means we want R to bring to show us those observations or those rows that do not have missing data, so that their data is complete. That's what complete cases means. So if I click Control Enter here, if you look at the console, so I've selected name, gender, height, and hair color. Now R has filtered only observations in which there are no missing data. How do I know that? If I remove this one, let me just remove this and just run the first code. So if I just say Star Wars and I select this 4 and I click Control Enter, if you look at this place, this is a table, that's a data frame, which has 87 rows and 4 columns. So these are the 4 columns: name, gender, height, and hair color. And then it has 87 rows or 87 observations. But when I remove the filter is to remove the missing data, let me put in back that I removed. So if I run this code right now and I go back to the console, you can see here R says it has 73 rows. Initially we saw it was 87, but because it has removed the rows in which there are missing data, they are now reduced to 73. So this is showing us the rows where there are no missing data, but I want to see those rows that have missing data. So if you remember yesterday, we talked about an operator, which I said means not. That's the exclamation mark. So I can put an exclamation mark in front of complete. So here I'm asking our filter cases which are not, filter out those that are not complete cases. That's what this exclamation mark is saying, not complete cases. If I run this code, so if you look at the console right now, it has filtered out those ones that have missing data or that are not complete. So we can see under the gender variable, it has some missing data. You can see these 3 missing data. Under the height variable, it also has missing data. Under hair color, it also has missing data. So sometimes we might just choose, like what we did in height, to remove the missing data from that column, so that we can be able to work, for example, like calculate statistical parameters on it. At other times, we might want to replace the missing data with something else. For example, in this height, we know that when we remove the missing data, the mean of the height is 170, I think 174, right? Let's go up and see. Okay, yeah, 174.358. So let's say 174. So sometimes when you're dealing with missing data in a numerical variable, you might just choose to replace the missing data with the average of that variable. That's a common thing that can be done to deal with missing data. You replace the missing data with the average value of the items on that variable, and that will not really affect so much your data analysis. That's one way of dealing with missing data. So for example, in this height here, where these missing data are, we can actually replace this missing data and say, okay, replace all the missing data in height with the mean, which is 174. And how do we do that? We just tell our Star Wars using a pipe operator, and then we still select the variables we want to deal with, which is name, gender, height, and hair color. And then we put in a pipe operator and we say mutate. So I'll work out this another place where we use mutate, and we're using another function in with the mutate now instead of the recode. So we say mutate. We tell R first of all. Now remember I said if you're using mutate, it will either write over an existing variable or it will create a new one. So let's assume we want to work on height, right? Okay, I want to retain the height that is there already, but I will create another variable. So I'll write height underscore new. Let me write new. So it means what I'm telling Arna is that retain the former height and then write create a new variable called height new. So what do I want it to do with height new? I want it to replace the missing data. There's a function called replace NA. So in replace NA, what do I want to replace? I want to replace the height So I want to replace height, the NA in height. I want to replace it with what we say the mean is 174. Or let me replace it with something that would really show us the work that. Let me use 5555 for example, just as an example. So what this code is saying, we told our the data sets that they're working on, and then we selected the variables I wanted to work with, and then we said mutate. We're asking R to create a new variable, but what we wanted to do with that new variable, in that new variable, we wanted to replace the missing data of the height variable with the value 5555. So if I run this command, Control Enter, what happened? Input must be sorry, mutates height equal to replace any. That's my mistake. In this line, select name, gender. There's a mistake on this. What mistake? Okay. You see, we didn't put a comma between height and hair color. So it's assuming height, hair color is one single variable. So that's why this mistake came. So we'll put a comma here. Okay. So if we run this command again, fine. So it has run. So if you look at the new answer it gave us, we have name, gender, height, and hair color, which are the 4 variables that were there before. Now it has retained the former height, which is this, and then it's, where is our replacement now? Let's view it so that we can see, because sometimes in the console it doesn't give the entire data set. So we're putting in a pipe operator here and we say view. So if we view this, so if we look at this height, let's look for the missing data in heights. Okay, so under height, see missing data NA. And in the new height underscore new, it has replaced the missing data NA with 5555, which was the instruction we gave. So can you see what we did with that? So that's another way to deal with missing data. Let me see if there's another missing data within heights. Okay, good. So these are also missing data within height. and it has replaced all of them here with 555, 5555. So that's how to deal with that missing data. Okay, so we've come to the end of today's session. This session will end in another few 1 minute or so. Do we have any questions? I'll send you the videos so that you could watch. I know we discussed quite some technical things today, but once you watch the videos and begin to practice, watch the videos, whatever we've done here, replicate them on your system. Watch the videos, pause it, do what we've done on your system. Like that, you begin to get to know it. You begin to get there. Sometimes it can be frustrating because you missed a comma here or a full stop there or something like that. But the more you do, the more you get used to it. I promise you, if you do that, you would really get it. Any questions? Any questions? We'll have a minute to go. Hello, Solomon. I can't hear anybody. Anyone saying anything?
Look, if I said if there's any question, I'll go back. I'll reach out to you.
Okay, it's all right.
Okay.
Okay then. Thank you all very much for being at this session. Please try and watch the videos and practice. We'll meet again on Saturday next week at 3 o'clock. If you have any issues within the week, you can do me a WhatsApp and then we'll try to see how we can tackle it. Otherwise, have a blessed day. Be good. I love you all.
Thank you, sir. Love you too. Thank you.
Bye.
Thank you, boss.
Bye.
Thank you.